Hello and welcome. In this video, we're going to be talking about the integration of special functions. These functions include trig functions, so basically sines and cosines and tans, and the integration of exponential functions, so functions like e power x. And we have a special function where we want to integrate 1 over x with respect to dx. We will look at all that in this video over here. So basically, before I start, I just want to remind you that we know that differentiation is basically the opposite of integration with respect to dx. So when I differentiate a function, so d by dx of f of x, I get f dash of x. And when I integrate f dash of x by dx, I get back f of x plus c. So basically, differentiation and integration are opposites, okay? And we will use this to help us in differentiating our functions today. So first of all, let's start with the trig functions integrations. So let's start with the basic ones. So we know that integration of cosine of x with respect to dx, this is going to give me sine of x plus c. And from here, I know that the differentiation of sine of x is going to give me back cosine of x. Okay? And integration of sine of x with respect to dx is going to give me negative cosine of x plus c. That means that the differentiation with respect to x of cosine of x is going to give me negative sine of x. This is super important, and this looks like a circle, okay? The next thing I want to look at is integration of tan of x. Integration of tan of x with respect to dx is ln of secant of x. And these have proofs in techniques that we will learn later, such as u substitution and integration by parts. We will look into all of these, but for now, I just want you to know these integrations. So also, that means that the differentiation of ln of secant of x is equal to tan of x. Okay, so if I integrate something, it gives me an answer. If I differentiate the answer, it's going to give me back the original thing. This is basically integration and differentiation. Okay, continuing, let's do the integration of secant of x by dx. This is going to give me an answer of ln secant x plus tan of x, all under the modulus plus c. That means that the differentiation of this thing is going to give me back secant of x. So differentiation of ln secant x plus tan x is going to give me back secant of x. Okay, continuing the trig functions, we have now integration of cosecant of x with respect to dx. This is going to give me ln of cosecant x minus cotangent of x plus c. This means that when I differentiate what's inside, so when I differentiate ln of cosecant x minus cotangent x, this is going to give me back cosecant of x. Okay, now integrating cotangent of x with respect to dx is going to equal ln sine of x plus c. That means when I differentiate ln of sine of x with respect to dx, this is going to give me back cotangent of x. Okay, this is super important. So these are the usual, the 6 trig functions that when we differentiate we get, when we integrate we get their answers. So let me just do like a split between integration and differentiation. Okay, so these are the integration of the 6 trig functions. Now what we can do is we can look at the differentiation of tan of x is equal to secant squared of x. That means that the integration of secant squared of x with respect to the x is nothing but tan of x plus c. Okay, and again, the differentiation of cotangent of x is equal to negative cosecant squared of x. That means that the integration of cosecant squared of x with respect to dx is going to give me negative cotangent x plus c. Okay, now I know that differentiation with respect to x of secant x is equal to secant x tan of x. So that means that the integration of secant x tan x equals, with respect to dx of course, equals secant x plus c. Okay. Furthermore, we know that the differentiation of cosecant x equals negative cosecant x cotangent x. That means that the integration of cosecant x cotangent x with respect to dx is going to give me negative cosecant of x plus c. Right? So these are the most important trig integrations and the ones that you will need to familiarize yourself with, okay, in order to solve the questions. Okay, so these are trig integration, trig functions integration, the most famous ones. Let's take a look at integration of exponential functions. So when we have e power x, so if you remember from the differentiation video, which I'll leave a link to in the top right hand corner, d by dx of e of x is e power x. That means that the integration of e power x with respect to dx is nothing but e power x as well plus c. Okay, so the integration of e power x is e power x and then plus the constant of integration. Furthermore, one of the most important ideas is that integration of 1 over x with respect to dx. Okay, now this you can rewrite it as x power negative 1 dx, and then you can use the power rule that we learned in the first video, which I will leave also a link to in the top right hand corner. What we learned is that we add 1 to the power and then we divide by the new power. So if we're integrating x squared with respect to dx, this is going to equal, we add 1 to the power, so x, 2 plus 1 is 3, and then we divide by the new power, which is over 3, and then plus c. If we try to apply that here, we're going to have a problem. Why? Because x power negative 1. Okay, adding 1 to the power, it means that x power negative 1 plus 1 is basically x power 0, and then we want to divide by the new power, which is 0. However, we cannot divide anything by 0. This gives an undefined answer. So what is the integration? So now that's a problem. What is the integration of 1 over x, or x to the power of negative 1? The integration of 1 over x is basically ln of x, and this is the modulus, okay, absolute value. Okay, so the integration of 1 over x is basically ln x, and then we never forget the constant of integration. So if you want to differentiate with respect to dx, with respect to x, we want to differentiate ln of x. This is nothing but 1 over x. Okay, so this is also a super important idea that we will use a lot. So exponential, this radical integration, in addition to these trig integrations, these are the most common integrations that we're going to encounter, and they are the basic integrations that we need to familiarize ourselves with in order to solve integration problems. Hope this video was helpful. Thank you so much for watching, and have a good day.